Hello there. I had this idea of making Nixie clock for a while, but just making usual Nixie clock would be too easy. So I decided why not to make Nixie clock with different gases. Also I have this vacuum pump and argon tank around, so why not to use them. Actually here you can see the final result, but I want to show you the whole process in this video. At first I didn't know whether if it's even possible to make, so I started experimenting with regular vacuum tubes, because they're useless anyway. So I opened it up and attached the valve to it and tried to glow gases. I evacuated air from the tube and tried to glow it in Tesla coil field. As you can see, that works pretty well. Next, I tried different power sources like plasma globe generator. It makes streamers. And I also tried to apply high voltage from Tesla coil directly, but that was too much overkill. Didn't go well. I experimented further. I came up with using this high voltage supply, and actually it worked pretty well. As you can see, the glow is stable. Here's interesting effect. Yeah, after some attempts I managed to achieve stable glow. I learned how to control it. Here you can see perfect glow. And in this experiment I even managed to make that sticky glow, just what we wanted. So next I used the real Nixie tube and I attached valve to it like this. Using silicone seal. Actually that works pretty well. Here the pressure is too low and it's kind of foggy, but you still can see the number that it's showing. Like this is 3 clearly. And here I adjusted the pressure, make it slightly higher, and it works way better. And here that's just air, alright? Already looks pretty cool. Here I'm trying different pressures, as when the pressure is too low, it's kind of becoming foggy. When pressure is too high, it's burning. So the pressure needs to be just right. And the discharge is pretty controllable. That's cool lavender color that I wanted to achieve. And also at low pressures, it also kind of burns red hot. Here's the interesting effect. After all my tests, the tube became toasty. It has yellow deposits and soot and all kind of... well, it's a mess. But, as you will see in the next shot, which was taken way later than this one, it fully recovered somehow. So when I open the valve and refill it a couple of times, it recovers. That's very unexpected. Okay, next I tested different power supplies. The first two are 220 volts, but they are extremely noisy, both electrical and audible. This one was good, but it overheats and not powerful. And this one is perfect. So that's 555 timer, key, transformer and voltage multiplier. I even modded it to add extra 25% power. This power supply is the neon power supply, but it's way overpowered because it outputs like 100 watts, way more than I need. The next problem is switching. Since I'm using high voltage, I cannot use semiconductors for switching, so instead I used reed relays. So I bought these Soviet-made reed relays, and since my X-ray cannot penetrate it, I decided to open up one to see what's inside. And it's pretty curious. So inside there is like a copper coil and magnetic switch Those relays aren't rated for kilovolts either, so I came up with a trick called good old zero voltage switching. So I disable high voltage with solid state relay, then I switch relays, then I enable it again. So this way high voltage doesn't harm relays, and this way I can switch them. And here's the setup that meant to prove that this concept will work. I connected microcontroller, optocouplers, relays, and high voltage power supply to the neon tube. As you can see, it's working, switching, high voltage switching working pretty great. Right now the pressure in the tube is not correct, but the point of this experiment is to prove that switching working, and it does. Next, I needed to make equal pressures in all 4 tubes, so I needed 4 tubes, alright? And I needed to be equal pressure, so I made this adapter from copper pipe, vacuum tight. Then I attached it to tubes like this. So I opened tubes up, attached pipe. Oh yeah, there are, of course, silicon seals. So this is Nixie assembly. Here's the full design of the device. Here's the frame, which is 11 centimeters cube. Here's the Nixie assembly that you already saw. Here's the relay assembly. All design is modular, so each module can be separated. Here's electronics parts. There is like controller for, 5 registers, real-time clock, and stabilizers, power stabilizers. All right. Here's the main power supply. Here's the high voltage power supply. Here's the power supply for orange variant, orange Nixies with dimmer. Here how it looks like assembled. I will not show the assembly because I didn't film it. Alright. It took quite a while to assemble it actually. Yeah, it can be controlled from USB. It doesn't have buttons. Here I'm showing how I fill tubes with gas. It's pretty easy. You just open the tank, make atmospheric pressure, then close the tank, then evacuate until it glows. Yeah, like this. Sometimes it can be tricky to light all 4 tubes at once, but it's manageable. So sometimes you need to like knock them a bit. Once they lit, they usually stay lit. So here's the clock with the air Nixies, air field. I like the color. And here's clock with argon. It's more white-ish. Even better. Have you seen Nixie clocks like this? I bet not. Alright. I also made that LEDs that match the color of tubes, either they're orange or lavender. Here you can see no external tubes attached, and it works and looks great, right? And the design is intentionally so you can see the all inner parts. So all the magic is visible. Here how it looks like in the dark. I also dimmed LEDs with PVM a little bit because they're too bright otherwise. And you can see it switching works well. And here's the orange, good old orange Nixie's version. It doesn't have high voltage supply, it just uses whatever voltage is in the grid, just rectify it, and yeah. So it's powered from about 300 volts or something, but it has dimmer, so I can adjust the brightness. Here's comparison side by side. Which one do you like the most? Which one do you like more? Anyway, I hope that was interesting in some way. Tell me what you think. Feel free to ask questions in the comments. See you around.